hesitated. Whoa. Drop it down to the floor, making me want you more. Come on to me, Lord. Sesame me more. I'ma take you to the bar. You know you want.
Hi pupils, today our topic of discussion is differentiation of trigonometric functions involving powers. So let's start with the derivative of sine to the power of n fx. So you only need to apply the general rule for the questions. So the rule says differentiation of sine to the power of n fx, bring the power down, subtract 1 from the power, and then multiply by the derivative of the sine functions, that is, the derivative of sine fx. So the answer would be n multiplied by sine to the power of n minus 1 fx. So derivative of sine fx, we have seen in our last session, it's cos fx multiplied by the derivative of fx. So I repeat, differentiation of sine to the power of n fx, it's n multiplied by sine to the power of n minus 1 fx. Derivative of sine fx, it's cos fx multiplied by the derivative of fx. So let us try now to apply it in some questions. Derivative of sine to the square 3x, bring the 2 down, subtract 1 from the power, so you have 2 sine 3x, multiply by the derivative of the sine function, that is sine 3x. So derivative of sine 3x, it's cos 3x, multiplied by the derivative of 3x, which is 3. So final answer, it's 6 sine 3x cos 3x. Second example, derivative of 4 sine cube into bracket 3 minus 2x. So you need not worry about the constant which is in front. Simply take the constant, multiply by the power, subtract the power by 1, and then multiply by the derivative of the sine function, that is, multiply by the derivative of sine 3 minus 2x. Derivative of sine 3 minus 2x, it's cos 3 minus 2x, multiply by the derivative of 3 minus 2x, which is minus 2. So final answer, it's minus 24 sine squared 3 minus 2x, multiplied by cos 3 minus 2x. Now let us proceed with our next example. Derivative of sine to the power of 4, 1 minus 4x cubed. The answer is bring 4 down, subtract 1 from the power, which is now sine x cubed, and then multiply by the derivative of the sine function, that is sine into bracket 1 minus 4x cubed. So derivative of sine 1 minus 4x cubed, it's cos into bracket 1 minus 4x cubed, multiply by the derivative of minus 4x cubed, which is minus 4 times 3x squared. So final answer is minus 48x squared, sine cube into bracket 1 minus 4x cubed, cos into bracket 1 minus 4x cubed. Fourth example, derivative of sine squared to the power of 3. Same rule applies. Bring the power down, subtract 1 from the power, and then multiply by the derivative of sine function, that is the derivative of sine x squared. So derivative of sine x squared is cos x squared, multiplied by the derivative of fx, that is the derivative of x squared, which is 2x. Final answer, 6x sine squared x squared plus x squared. I repeat, it's 3 times 2x, 6x. So sine x squared to the square can be written as sine squared x squared cos x squared. Now we proceed with the differentiation of the cos function. That is the derivative of cos to the power of n fx. Same rule, bring n down, subtract 1 from the power, and then multiply by the derivative of the cosine function. So the answer will be n cos to the power of n minus 1 fx. Derivative of cos fx, it's minus sine fx, multiplied by the derivative of fx, which is fx. So our first example would be derivative of cos to the power of 4 2x. So we only need to follow the general rule, bring the 4 down, subtract 1 from 4, which is 3, multiply by the derivative of the cosine function, that is the derivative of cos 2x, which is minus sine 2x, multiplied by the derivative of 2x, which is 2. So it's minus 8 cos cubed 2x sine 2x. Next example, derivative of cos squared into bracket 3 minus 4x. So bring the 2 down, subtract 1 from 2, which is 1, multiply by the derivative of the cosine function, which is cos 3 minus 4x. So here you have 2 multiplied by cos into bracket 3 minus 4x. Derivative of cos function, it's minus sine of the function, multiplied by the derivative of the function, which is minus 4. So final answer, minus minus plus, it's a cos into bracket 3 minus 4x sine 3 minus 4x. So our next example would be the derivative of cos, derivative of 3 cos squared into bracket 3 minus 4x cubed. Same rule, take the constant, multiply by the power, subtract the power by 1, multiply by the derivative of the cosine function, that is the derivative of cos 3 minus 4x cubed. So here you have 6 cos into bracket 3 minus 4x cubed, multiply by, so derivative of cos 3 minus 4x cubed, it's minus sine of the function, multiplied by the derivative of minus 4x cubed, it's minus 4 times 3x squared. So final answer will be 72x squared, cos into bracket 3 minus 4x cubed, sine into bracket 3 minus 4x cubed. Fifth example, derivative of cos cubed square root of x. Same principle, bring the 3 down, subtract 1 from the power, which is 2, and then multiply by the derivative of the cos function, that is cos root of x, which is minus sine root of x, multiplied by the derivative of square root of x, which is half x minus half. So you rearrange it, and the final answer is minus 3 upon 2 square root of x, cos square root x, and sine root x. We now proceed with differentiation of tan functions with powers. So differentiation of tan to the power of n fx, same rule, bring power down, subtract 1 from the power, multiply by the differentiation of the tan function, which is sec square fx, multiplied by the differentiation of fx. So our answer would be like n multiplied by 10 to the power of n minus 1 fx, sec square fx, multiplied by the derivative of fx. So it's better to apply it now. Differentiation of tan cube 3x, bring the power down, subtract 1 from the power, and then multiply by the derivative of tan 3x, which is sec square 3x times 3. So final answer will be 9 tan square 3x sec square 3x. Next, derivative of 3 tan to the power of 5 into bracket 2x squared plus 5. So here we have added one constant in front of the function. So how to proceed now? So take the constant 3, multiply by the power 5. So 5 minus 1, which is 4. First step over. Then multiply by the derivative of the tan functions. So it's 15 tan to the power of 4 into bracket 2x squared plus 5 multiplied by, so derivative of tan of the function, it's sec squared of the function, multiplied by the derivative of the function, which is 4x. So final answer, it's 60x tan to the power of 4 2x squared plus 5 sec squared into bracket 2x squared plus 5. So our next question will be the differentiation of tan squared into bracket 3x squared minus 2 pi x. Same principle, bring the power down, subtract 1 from the power, and then multiply by the derivative of the tan function, which is sec squared 3x squared minus 2 pi x, multiply by the derivative of 3x squared minus 2 pi x. So derivative of 3x is 6x, derivative of minus 2 pi x is minus 2 pi. So final answer, 2 times 6x gives 12x, 2 times minus 2 pi gives minus 4 pi. So this would be the constant in front. A function, tan into bracket 3x squared minus 2 pi x, sec squared into bracket 3x squared minus 2 pi x. Last question. Differentiation of tan to the power of 3 cube of x. Same rule. Bring the power down. 3. 3 minus 1 is 2. Multiply by the derivative of the tan function, that is derivative of tan cube root of x, which is sec squared cube root of x, multiply by the derivative of x to the power 1 upon 3. So it's 1 upon 3 multiplied by x. So 1 upon 3 minus 1, it's minus 2/3. So final answer will be 3 tan squared cube root of x, sec squared cube root of x upon x to the power of 2/3. So my dear pupils, I hope you have enjoyed the lesson and you'll be able to practice well before your exam. So see you soon and it's goodbye.
You know you're driving me crazy. Anticipating the taste of your lips, yeah, I'm craving. No hesitating. Whoa. Drop it down to the floor, making me want